Hi and welcome to DCO. My name is David Capetti, and in this video I'll be going over how to create this base architectural building that has openings, it has doors, and it has windows. So a lot of techniques that I'll be going over here can be useful for many other designs. And if you're new to Grasshopper and haven't already, but wanted to try something more typical, this is something that you can learn a lot from. So thank you very much for being here, and let's jump right in. The first thing we'll do is bring in a base rectangle, and that's going to be our base geometry. So I have here my file. The units are going to be in feet, and then here I have a brand new file. So I'll go here and bring in a rectangle, and I'll use this create a rectangle on a plane. Now we can always change the plane location, but it's always going to give it to us here in the XY. We can change that location by going to construct point and then plugging that into a point, and we can always change the location now of where we want this design. This is one of the things I like to do to make sure it's a little bit more dynamic, and I can always change create a point here and change the location. So with that being said, if you're new to this channel, one of the things, if you don't see the script the same way, one of the things you'll notice is that I have display, draw icons, draw fancy wires, and draw full names on. This way you can kind of see all of the inputs and all of the icons. So now let's go here to a slider, and I'll just go to 20, and I'll create 2 of those. This way I have the ability to change the dimensions of the design using these 2. And so we can always change the name here. So I'll right click, change the number slider name to X and then Y. We can always change it later. So now with this rectangle, what we'll do is we'll take this and we'll offset it. So I'll go here to offset curve. Now I'll plug in the rectangle into the curve. And as you can see, it offsets, but it offsets to the outside. So what we need to do is bring in a negative component and plug in a slider for the distance. So I'll go 1.50. So that's 1.5 feet. And it's offsetting to the inside. Now what happens is technically walls are dimensioned in lumber, which is dimensioned in inches, not in feet. So for this to be, let's say, a 8-inch wall, I can't just go to 8 because that would be 8 feet. And I can't go 0.8 because that's going to be too small. So what we need to do is convert it from inches or from feet to inches. So what I do is I'll go here to divide by 12. Turning this into 0.139167. And this is going to be 3.5. So that's going to be 0.291 feet. And that's negative. So that's the way that I sometimes change the slider from feet to inches. And you can do the same thing if you want to go from, let's say, millimeters to centimeters and things like that. So with this one, we'll change this to inches for wall depth. The thing is, we can also have, let's say, the ability for it to be 0.5, which would be the wall depth in feet. So we can have 2 of the options. If we don't want to do it this way, we can do it this way. And it would also, just thinking right now, it would also be cool to create a calculator like that. Just one that says, you know, input in inches and input in feet, and then just have that, use that interchange, like have that ability to interchange it for anything. I think that would be kind of cool. So with that being said, we'll move on to the next thing, which will be to create a surface between these two. So to do that, we'll go to Boundary Surfaces. But actually, one of the things that will make it a lot easier is going to be using region difference, which is a cool technique to use. Rather than creating a boundary surface, you give the outer boundary, so curves A, and then you take the offset, which is going to be curves B. And now it's going to subtract the inside one from the outside one. Basically Boolean difference, but in 2D. And now we can bring in a boundary surface, which will give us that result. The reason for that is because when we do other region unions and other things like that, we're probably going to use this, which will work better. So with that being said, we're now going to move on to pick two of these lines here to move them and create two rooms inside, or divide this into 3 separate rooms. So create 2 different walls. All right, so now that we have this, we'll take the inside, actually no, we'll take the original rectangle, and what we'll do is we'll deconstruct it by exploding it. It's not deconstruct brep because we're talking about a rectangle. So I'll plug that into the curve, and we have our segments here. So we have 4 separate segments. We want to pick opposite curves. This way we can do, let's say, actually no, we want to pick just one. So we have 4 of these, and we want to pick one. And actually, just thinking out loud, we actually want to do the inside one because we want to pick one of these lines and move it in, and that way we don't have to account for the thickness of the wall. So now we'll take this line, one of these line segments. Here I'll go to list item and plug in the segments into the list. And by default, the index of 0 is going to give us this wall, and we can change that by bringing in a slider. So let's say 3. And so that's what list item does. It will pick an item. So we have 4 segments, and it'll pick one of those 4 segments by letting you use a slider and sort through them. Now that we have, let's say, this wall, we can take that wall and we can move it this way and create that gap first. So we'll go here to move, and we'll take this line and move it. In which direction? Well, it's going to be in the positive X. So we'll take this and we're going to bring in a component unit X, plug that into the motion, and then bring in a slider to move that over. So we'll go to 15. Next thing we'll do is we'll take this line and we will extrude it in the X direction. So extrude. In the unit X. By how much? Well, depending on whether you want to use the exact same wall thickness as the outside. Whoops, this is going to be negative here. Then we can use this output again, but if you don't want to do that, then we can take this, copy it over. Now we can have this as the wall depth. I'm going to go here into the extrusion. So this is going to be room size, and this is going to be wall number. Not really sure what to call this one because what we're doing is we're moving that over. So I'm just picking 3, and technically 3 is the one that I always want to pick unless, and the reason why is because we're using X, right? So it's moving this line in the X direction, and it's always going to do that. So if we rotate it or change anything around, it's always going to do it in the X direction. For this reason, I feel like 3 is the one that you want to maintain. So if that's one of the things you do want to maintain, you don't want to have a slider because you can move that around. I'll go here to index, set integer, and I'll go to 3. This way, it always picks this curve no matter what. Okay, now what we need to do is pick two opposite lines, these two opposite lines, and pick the center point. Or we could just pick one of those lines. What I'll do is I'll select this, make a copy down here, or I'll just bring in a new list item because that one has set the 3 as the index. This one we want to pick a different one, and let's say that one, so index of 0 is going to be this one, and we'll bring in an XZ plane, and we'll plug that into the midpoint of this one. So we'll get the midpoints of that line and then create an XY plane. It's going to be a YZ plane. Now we can take this and we can bring in the mirror component, which we can use the plane as the input and then take this extrusion as the geometry that we want to mirror. So we can take this now, let's move this around. Now we can move this to the room size. It's going to be here. And the overall size is going to be here. Now what I'm seeing here is that I am going to want to create a door along this wall. And rather than having to, let's say, do a subtraction on the wall, on both of these walls at the same time, I'd rather do it to one and then mirror it. So I see that there's going to be a few things that I'm going to want to do before I mirror it, but that's okay. First thing I'll do is extrude this outside wall. So we'll go here to extrude, and we're just working with basic forms here. We can always go into high detail in modeling, not necessarily all parametric. So now I'll start with taking this and extruding it. So extrude, in which direction? Unit Z, so up, positive. And then I'll go here to 12. Now that we have that, let's do the same thing to the inside walls. But we'll only do it to one of them. And like I explained earlier, it's because if we do it to one, we know that we can copy it to the other side. With this line that we used to create that wall, one of the things we can do is pick a point along that line. So one of the things we can do is go to evaluate curve, and we'll pick that geometry, that curve, and the parameter we'll use construct point to create a point along this. And in the X, we can plug in by how much it's going to move that point. So we'll go here to 1.500. And then 10. So it only moves it by 1.5 feet this way. And what happens is, once again, this is in feet. And technically the wall where the door starts, that's going to be measured in inches, unless you say like 6 inches, which would be 0.5 in feet. So for me, it sometimes makes it easier to convert it. But I do know that not everyone uses inches. So I'm just letting you know in advance. So here I'll just say 4 inches space from wall. Typically you want at least 4 inches from the wall. That way you can fit like at least 2 studs there before you create a door frame. So just keep that in mind. So with that point, right, we can then move it in which direction? Well, here we go -y, and then we can move it up. So let's go here to move this point in the y direction, but it's going to be negative because it's going in the opposite direction. And now we're going to plug that into the motion and then use the value. So here we can use 4.00, so a 4-foot door. And between those 2 points, we create a line. So let's go here to a line component. But this one is the line between 2 points, between the start point, which is this one, then the end point, which is going to be this one. Now we're going to extrude this up. And the cool thing is, now let's say, oh, we want this to be a 6-foot or 5-foot, 2 pair 30-inch doors, or this to be more, right? If you want it to be more of a gap there, we could do that. So with that being said, let's take this and now extrude it to the height of the door head. Door head is the height of the doors, and typically they're at 6'8" for like the typical standard ones, but more modern are going to be like 8 feet. So we'll go here to unit Z and then slider of 8. Now with this, we can extrude this surface in the X direction. So we'll go here to extrude in the X direction. By how much? Well, the same as the wall depth. So that's going to be the only thing is that if you want this to be centered, you would take a different approach, right? And we can even do it mathematically if we wanted to, like create an option, and I can show you that, because for me that's one of the cool things about Grasshopper, is being able to use mathematics to have some kind of fun and play some tricks with it. So with that, let me show you. Let's say we have the overall length of this. So we know that if I bring in a length component, then I can figure out how far this wall is. Well, if I want this point in the center, well, it's the length divided by 2. And that's by how much we would move this point. So let's move this point in which direction? -y. So we can copy these. Now it's at the center. Now I can use that point as my spring point for my door. You see that? So now that this point are both the same, this is the option of creating it at the center. But you're going to see that since this was created from this point over to the right, there's an additional step that we need to do. And I'll plug this in. Boom. It's in the center, but it's off to the right. So then we need to account for that, right? Whatever the door is, 3 divided by 2 is how much you move it by. And hopefully you're able to visualize that. If not, that's okay. Give it a shot. Let's go here to, let's say the door is 6, right? So if the door is 6, then we need to move it 3 feet this way. So I'm moving it. Now we're going to go which way? Negative. We're positive. So that's why it kind of messes up. Positive y by half. So divide by 2. And it's going to give us a component with 2 at the bottom. And now that's going to be the point that we use to insert it. And that centers it. So to recap, because I kind of messed it up there a little bit, it's because it's moving it backwards again, and we actually need to move it positive. So with that being said, what we did is we took this line, we got the midpoint, and since the door was created off to the right, then we moved this point back over this way, half of the size of the door. And that is what we do if we want to go in this direction. If we want to pick the exact center of it, that's the way to do it. The other way is going to be this way. So and here's the thing, we can add the option for both. So have this one in here, enabled, disabled, and then here have this one. So if you want to enable it, right click enable and then add that in. So that's another cool trick. Now we have the size here, and there are going to be a few other things that are added here, but now you have the option for that if you need it. So with that, we can take then the overall wall and subtract that door. So we'll go here to difference, solid difference, B reps A, and then B rep B is going to be the extrusion. And I'll disable the preview on both of these. And we have this extrusion. So now we can use this mirror component with the plane that's created exactly at that center curve. And we can plug that into this one. Plug our geometry into the plane or into the geometry, and then using that plane, we can copy that. So this way, we can move around the room size here. Next thing we'll do is create an opening. So there's going to be 2 openings, one on this side, one on this side, and then we're going to do another door here. And that will conclude that base geometry for like a building that has 2 separate rooms, 1 middle room, and then here it's just going to have an overall room with an opening on the front or the back. For this portion, we need to go back to our base curves, And we can use that same curve that we used for creating our wall. And we could pick the midpoint of that and use the same technique that we used before, but this one's going to be starting from the center. So we'll take this one and we'll bring in the midpoint. So we'll go here to curve midpoint, curve middle, and I'll plug in this one up here down into the curve. Then I'll go and create a rectangle. And I'll use this midpoint here into the plane. But actually, rather than using a midpoint, we're going to just take this point and we're going to move it both in the positive and negative y. So we'll move this point in the y direction, both positive and negative. I'm adding another input, holding down shift. Now I can create a polyline here on the vertices. Here, now we can pick a size of the window. So if I want it to be a 6 foot, so I'll do 6.00, and I'll actually divide that by 2 because it's going to do 6 feet this way and 6 feet this way, and that would actually be 12. We want it to do 3 and 3, giving us the overall size that we are looking for. I did times 2, so it's actually divide by 2. Next is we'll take this line and we will move it up to the head height. So this is going to be a little bit different than the door because we want to move this up to the same location as the door head. And it's not necessary because sometimes you will have window heads that are different locations, but that just, we already have that. So we can always change that if we want to. So it's at 8 here. So that's how big the opening is. We can see that here. And so we can use that Z vector to move the window up to that location. Now we're actually going to extrude it down to the size direction, Z, negative. And this is something similar that I would do at 3D modeling, right? We would take, let's say, the location of the window, bring it up to the head height, and then extrude it down for the size. Lastly, extrude this in which direction? Negative X. So unit X, and I'll plug that into the negative, and here into the direction. Now, by how much? Well, we know it's the same amount as the wall. So technically, we don't have to pick one because we already have that here. So we'll go to this value here into the X. Actually, not that one. It's going to be this one. Now I can plug in the overall, so disable to prevent everything. And I can use the same mirror plane to mirror it to the other side, and then we'll subtract it from the overall size here. So let's what we need to do is take this, we'll make a copy, slide it down, tap Alt, and you can make a copy, or Control C, Control V. Now we'll plug in the geometry into the same, that input, since it has the same plane, well, it's going to take what's on this side, copy it to that side. Now we can use this and this. So we'll plug those into one input. This way we keep things a little bit more organized, and we only need one input to plug into the subtraction. Now we'll take the overall shape, which is going to be here. And sometimes when I kind of get in the flow of designing, I don't label them right away. So I will go through and relabel this, at least to kind of clean it up to see what are the inputs and outputs. And when I post it to the website, I'll make sure to have that. So here, let's go to 12. I'm going to go into, here's another trick. You can double click here. It gives you a relay, so you can bring the relay over here. Now we can subtract, knowing that that's the input. So we'll go here to difference or subtraction. Solid difference, that's what it is. Now we'll plug that breps A and then breps B. And now we'll disable the preview on those windows, although it's cool to keep those because those will be kind of the base forms for the windows. So we can even use that to work our design. Other than that, we do want to disable the preview on this because that will overlap with everything. We don't want that. So we have this, we have our breps. Disable the preview on those because they look like they're overlapping. And lastly, we'll bring in those walls and bring them together using union. So this one, holding down Shift. And if you wanted to kind of be a little bit cleaner, sometimes brep or geometry, whatever kind of output component you want, that's okay. And then here we'll have windows. Now let's go look for the doors, because here we have this door. And we can use the mirror component once again. I'll just copy this here. And even though we don't need to mirror the door because we mirrored the wall that had the subtraction already, well, it's okay to bring that in so we can have base forms for the doors. I'll disable the preview on all of this stuff. And what I do is I'll select, middle click, and then this disable preview, or the guy with the, but here's the thing, I think with the Mac it's a different one, so you might do space bar and then have to configure it. But regardless, we have I'm gonna see why we have twice. Oh, this one. Well, here's the thing. Technically, I can take this into another brep, but that's kind of redundant. What I can do is double click on the wire, brings in a relay, and then here bring in a relay. That relay, oh, actually I messed that up. This relay gets disconnected, and then this gets connected here. And now we can just take this over here. So let's go back and move some of the sliders around, see if everything's still working. We have the overall size. And this could also be used for creating like base tiny homes or like smaller structures. The only thing that's messing up here is the wall depth in inches. When I do this, it's not doing the same as the other one. There's something going on with the extrusion here that it's going to have to do with this. There it is. Okay. So what it was is the offset was different for the outside than for the inside. Either way, that works now. Now let's go to the wall height. 9. You go here to 10. Room size. That's how big the room on the inside, on each side is going to be. Now the wall height here, giving us a different height than for the interior, which is okay. But I would say if we want, we could have the outside walls and the inside walls be the same height, and that will simplify some things. We can always have the inside be a different size, so we can have that option here, but we do want this one to be the same as this one. Space from wall is going to be how far that door is located from the wall. The opening. I've gone ahead and kind of labeled everything and organized it a little bit better. What we're going to do now, and this will kind of conclude the tutorial, is going to be to use that point, the midpoint that we picked here where that plane is located, and we want to create a door there. So here where we have the midpoint, now we're going to take this and we're going to create a move component. So let's go here to move. We're going to move that midpoint up in the Z direction. Or we can move it in the X direction. Then I'll plug in a value for the X. And since we're going to do it to both sides, we have to divide this by 2. Now we'll take this and bring in a negative component. And holding down Shift, I'll add that into the input. Now I can take these two and plug them into a polyline. And extrude it up. So I'll go here to extrude. And the height is going to be the same as the door height. So wall height, go here to door location, door size. And now we can take that extrusion and extrude it here along the Y direction. So extrude Y. We want in the negative direction. And now we want to change the Y into the size of the wall. So we'll take this value, plug that into the Y. And so we basically have the form of the door, which we can bring into another VREP or geometry component and bring it out here. Disable the preview on this one, but let's not forget that we have to subtract it from the overall wall. So let's take a look here that we have this wall and it subtracts these windows. Well, why don't we plug this one into that one? It'll subtract it. But that actually causes an issue. So we need to plug this into VREPs B, flatten the input. This way it does it all at once, all of those in one rather than having them do separate. And that's important. Now let's disable the preview. Now we have this wall, this door, so let's move that around. Let's move out the size. And if we want the size door height to be larger, right, then we can change that. Right? If we want not the X, but this one. If we want a different value than the window and door head, then we can use front. We can do something like this, where we can change the door size for the front to be a little bit bigger. So this is going to be front. I'll be sharing the time lapse of how I cleaned this up too. So hopefully you found that interesting. Thank you very much for being here, and I hope to see you next time. If you'd like to get a hold of the script that I created for this video, check out my website, capettidavid.com. There you can become a Script Vault member, where you can access all of the video scripts that I've created for my YouTube. You can access also the script store, where I have optimized scripts. And lastly, if you want to learn Grasshopper and you've never tried it, or you want to share that with someone, I have a 6-module course that will help anyone get started. I post videos like this that will teach people how to get started using Grasshopper, so make sure to subscribe for future content. I appreciate you being here, and I hope to see you next time.